Okay, let's take a quick look at a setup for what we call a stoichiometry problem. Now, due to the constraints of how much room I have here to write on, I'm not going to actually do the calculation for you, but I'll show you the general setup. And a stoichiometry basically means we're going to have a chemical reaction like you see above here. And this, first of all, in order to do any stoichiometry problem, it is a must that you have a balanced equation. Okay, and the reason we got to have a balanced equation is these things right here are critical in a stoichiometry problem. Notice there's also a 1 right there. So what we call the mole ratio. And that basically tells us how these chemicals, these compounds, interact with each other and in what ratios they are needed to make a reaction and in what ratios they are produced. So let's get to the setup. A typical stoichiometry problem basically gives you a starting amount of something. Some compound or element within your reaction you had to begin with. So in this case, we have 100 grams of chlorine. Okay, grams aren't usually the best way to measure something that's in a gaseous state. We're just going to go with a generic setup so you can see the general structure. So if we start with 100 grams of chlorine, a typical question will say, if we begin with 100 grams of chlorine, how many grams of sodium would be necessary to react with this? Or it could ask, how many grams of sodium chloride are produced? Okay, it's going to ask you about some other species or some other chemical within the reaction. Now, let's just begin this setup. You always take your starting amount and let's label what it is. Okay, and I'm just going to draw one giant fraction here. Okay, I write my conversions a little different than some people, but you'll get the general idea here. So I start with 100 grams of chlorine gas. Now, the first step in every single stoichiometry problem is to make sure that you get your amounts into moles, because that's how we compare amounts within a chemical reaction. So the first thing I'm going to do is I'm going to change grams of chlorine into moles of chlorine. Okay? Now, if I'm going to change it into moles of chlorine, whatever units are right here are going to have to go down here also so I can cancel them out. So grams of chlorine goes here. And now notice I'm going to set this whole thing up without putting any numbers in until the very end. Okay, so if I do that, if I do what I just have written out here, I've got grams of chlorine cancel out. Now yes, some numbers are going to go in here. There's definitely going to be some numbers that are put in this conversion, but for right now, I'm not going to do that. Okay. Now once I change it from grams of chlorine to moles of chlorine, as soon as I get into moles, I can basically change it to any other compound that I want. And in this case, if I'm looking for sodium, I'm going to write moles of sodium right here. Okay. And basically, this juncture right here, from here to there, I can change it to anything within the reaction that I want, any element or compound that's shown there. And now, if I'm going to change it to moles of sodium, I want my moles of chlorine to cancel out, so that means moles of chlorine has to go down here. And now I've got basically my amount at this point is converted into moles of sodium. I would like to get it back into something you can measure. Nobody really measures moles physically. We have to measure something else, like grams. So I'm going to change moles of sodium into grams. Whoops, let's do this in blue. Grams of sodium. What that means is moles of sodium must go down here so that they'll cancel out. Oops. All right. So if I do this conversion, I should start with 100 grams of chlorine and end up with something in grams of sodium. Now, where do the numbers come from? Okay, they always come from basically the same spot. In our first conversion, right here, we have moles of chlorine to grams of chlorine. That comes from the periodic table. The periodic table tells us what 1 mole of everything weighs. So if I look up the molar mass of chlorine, I would find that it is about 35.5 grams for each chlorine, and since there's 2 of them, I would put 71 right here. Now, same thing happens over here on the other side. If I'm going from moles to grams, I'm going to look at the periodic table. And I'm going to see that sodium is about 23 grams, and that represents 1 mole. Now, the only other thing we got to worry about here is how we how we relate moles of chlorine to moles of sodium, and that's where our balanced reaction comes in. Notice sodium has a 2 in front of it, so 2 moles of sodium react with 1 mole of chlorine. I basically have my answer in front of me now. I just have to do a little bit of multiplying and dividing. So basically I'm going to take 100 times 2 times 23, and I'm going to get an amount out of that. And whatever that amount is, I'm going to divide it by 71. Now notice I didn't include the ones in there because they don't really affect the calculation, but they're there for a reason. They're there to help you set things up. So if you approach any problem like this, I'm not going to do the actual calculation here, it'll take too much time, but you can see how to set it up. If I were to do any problem like this, basically if I'm able to put these things right here in these units, it tells me where every measurement or every conversion factor should go. And then it comes down to just multiplying and dividing one time and I'm finished. So that's the basic setup for a stoichiometry type problem.